Okay guys, we're going to go over question number 24 on your daily practice. We've got a electrochemical cell here, and it says when tin metal was placed into a solution of niobium 2 fluoride, there was no evidence of a chemical reaction. When the switch is closed in the cell represented above, the voltage reading is 0.96 volts. So let's focus on the first sentence first. When tin metal was placed into a solution of niobium 2 fluoride, I'm going to try and draw that out so you can see what it looks like. So this is a beaker, and this is going to be our solution of niobium 2 fluoride, and this is going to be our tin metal. Okay, so we've got tin here, and we have some niobium 2 fluoride. This is different than the cell to the right over here. Alright, so basically it says there's no reaction, and what that means is the tin did not, this is not happening, but I'm going to show you, the tin did not turn into a 2+ ion, and the niobium did not deposit onto the tin metal as a solid. Okay, so that did not happen. So I'm going to write that over here. Did not happen. Whoops. So our tin did not oxidize into tin 2+ ion, and our niobium ion did not reduce into niobium metal. Alright, so this did not happen, which means when we put the tin and the niobium electrodes in this cell, the opposite's going to happen. In other words, we're going to reverse all these. The tin 2+ ion is going to be reduced into tin metal. Okay? And the reason I know this is going to happen is because when we put the tin metal into the niobium fluoride, it didn't react automatically. So the opposite will happen, which means our niobium will be oxidized into niobium ion. Right here, tin 2+ ion is turning into tin metal, and it is gaining electrons to do that, so our tin is being reduced and our niobium is being oxidized. And from that, if tin is being reduced, if you remember the red cat, so reduction happens at the cathode, our tin 2 ion is being reduced, which means this must be the cathode, because our tin 2 ion is being reduced to tin. This must be our anode, because our niobium is being oxidized into niobium 2+ ion. Letter A, it says write the half reduction, half reaction that occurs in the cell. Well, this is our reduction, so that's going to go right there. B, write the equation for the overall reaction that occurs in the cell. So basically these two reactions right here, our tin 2+ ion and our niobium solid, that's the reaction that's happening. Our electrons are already balanced, so I'm going to get rid of those. And now all I have to do is add everything on the reactant side, and that's going to yield adding everything on the product side. So that would be tin 2+ ion, and that's aqueous. You guys need to get used to doing that. Plus niobium solid, sorry my pen is doing something funky here, is going to tin metal plus niobium ion. This right here goes in letter B. Let's go up. We've already identified the anode in the cell, and the reason why this is the anode, niobium is the anode, is because niobium is being oxidized into niobium 2+ ion. Now it says on the diagram above, use an arrow to clearly indicate the direction of the electron flow as the cell operates. Alright, so we know our tin ion is gaining electrons, so that means that the electrons must be flowing to the cathode. Our niobium metal is being oxidized and it's releasing electrons, which means right here the electrons are going to be moving away if niobium metal is releasing electrons. Okay, E, F, and G, I'm not going to go over those. There's enough of those examples in your notes and on the daily practice. I did want to say that in order to find this half reaction right here, or the standard reduction potential, we have to give you the 10. Right here is negative 0.14 volts, if you want to go ahead and do that. There's something that this question doesn't ask, and I wanted to be sure that you understood it, and that is your salt bridge. So when your tin 2+ ion is being reduced into tin metal, your positive 2 charge here, or your charges between your tin and your fluoride, becoming unequal. And you need more positive charge to move in here. So your potassium right here will move towards the cathode compartment. Over here, let's look at the anode compartment. Your niobium metal is turning into niobium 2+ ion, and when it does, you have more positive 2 charge in your anode compartment than you have negative charge. So what's going to happen to equilibrate that is the fluoride ion in the salt bridge will move over into the anode compartment. Okay, because these charges in your solutions need to stay equilibrated in order for the cell to continue to work. Okay, the key is on Canvas if you'd like to check it.